Thank you. All right, good morning, everybody. Thanks for joining us this morning. I'm going to walk through an overview of Wi-Fi 6E, a lot of the advantages that it provides, and some of the products portfolio that Cisco offers in this new Wi-Fi 6E band, or the 6 gigahertz band. As Michael said, we have a a small group here, so feel free to raise your hand and ask your question live. Do I see a hand raised? Okay, maybe not. But feel free to jump in or just add your questions in the chat. All right, let's get started. So in this slide kind of shows, can someone just confirm that they can see that I forwarded the slide or I advanced
Yep.
to the next slide?
Yep.
Okay,
We're
thank you,
all
Michael.
set, Benny. Yep.
Great, thanks. So yeah, so this is kind of the evolution for the last 15, 20 years of Wi-Fi. And we are now the current latest and greatest is Wi-Fi 6E, and I'll be diving deeper into what that all means for everybody. I won't go through and read the bullets because I'm going to be diving into each of these in greater detail. By the way, they went, if you hadn't realized, they went from, saying the full standard like 802.11ax wave 1, AC wave 1, wave 2, 11ax to just now naming them with numbers. I think it's just less words to say to describe what standard you're actually talking about. Okay, so in the previous standard or the most recent standard prior to Wi-Fi 6E, we got 11ax or Wi-Fi 6. What that brought to us was more bits in the air. What that means is being able to transmit more data. So we're up to 1024 QAM. So every pixel or dot you see in those 4 quadrants represents a bit of data. And with that much data, it just meant better use of the frequency. So in 802.11ax or Wi-Fi 6, we also got other things like BSS coloring. Why is that an advantage? Well, if you see the channels shown there, those numbered octagons, no, those numbered blobs or shapes predominantly show channels 1, 3. It should be showing 1, 6, and 11, but BSS coloring gives you the advantage, especially into the 2.4 band, 2.4 gigahertz band, that you potentially could use it again. Before BSS coloring, the 2.4 gigahertz band was just way saturated with a lot of interference, and ultimately that affects user experience because throughput was way down. So with BSS coloring, every bit that goes over the air, if you're talking to an access point from your client, that data is tagged. So the AP can say, okay, this piece of information or this data is meant for me. I can ignore everything else. So it's actually a tag that's placed on the data that's sent over the air, which and they've just called it basic service set or BSS coloring. With OFDMA, now we can actually transmit data, and the T1, T2, T3 are time slots, and we can transmit data from multiple clients at the same time. And then there's a negotiation that's done between the client and the AP, and ultimately the AP can say, okay, client 1, 3, and 7 can transmit, everybody else hold off. this is a lot more efficient use of the airway of the airspace or the RF space frequencies, because before we had OFDMA, each client could transmit, and only that one client transmitted. So it's, think of it as a UPS or FedEx truck leaving the distribution center with just one parcel or box, and that truck left the station, delivered its box or package, and then as soon as that was done, the next truck leaves with just a single package. So as you can imagine, very inefficient use of these RF frequencies. And then with TWT, or target wait time, that's a huge savings in battery life for clients, because now clients don't have to wake up and wait for their chance to speak to the AP to ask, hey, do you have anything for me? If you don't, I'm just going to go back to sleep. Well, now there's a negotiation between the client and the AP, and they actually negotiate when that client should wake up to check in on the AP. So definitely a lot more battery life on your clients. Download, upload, multi-user MIMO. That's also was introduced in 11AX. That's a little trickier. You can see those three different colored beams coming from the access point towards the client. It's a little tricky because you need separation, you need timing, et cetera, but it is available. So potentially, if the conditions are right, you could have three clients, up to three clients simultaneously speaking and receiving from the AP. So couple that Wi-Fi 6 11AX now with 6E to the right, with all of this additional spectrum, and I'll cover what I mean by additional spectrum in a minute, with the ability to do wider channels. It's clean RF because there's a lot less interference now in this new frequency band, this 6 gigahertz band. And it's also not backward compatible. In other words, if you have a device that can only support 2.4 and a 5 gigahertz band, but does not have a 6 gigahertz radio, it's not going to be able to talk in the 6 gigahertz frequency band. So there are no quote unquote slow devices. Think back to the days of the B clients. I refer to them as slow talkers because they get on the air and get off the frequencies slower. So every other client who is faster and more efficient has to wait for this slow client to finish its transmission. And then, as I mentioned, airtime efficiency. Any questions, Michael, that I can address at this point? Okay, I'm going to take that as a no. So moving forward, build out this slide here. So I think I've covered most of these, but as I mentioned, it's not backwards compatible in that it's a clean frequency, but that doesn't mean that the device manufacturers are only making client devices that are 6 gigahertz only. They do have the 5 gigahertz and 2.4 gigahertz radios in those devices. So in that sense, it's backwards compatible. But if, so it's in fact, all manufacturers thus far have been adding all three radios in those devices, so that if they walk into an environment that only has 2.4 and 5, they can still associate and get on the wireless. I will address security The only thing I want to add here is that with the new security requirements for 6 gigahertz, it's a lot safer. But it also offers some challenges because you now have to support the previous generation method of negotiation between the client and the AP from a security perspective, and also these new security standards. So what does that all mean in your environment? And I think I've covered most of these others. Yes. Okay, so what does it mean to have the 6 gigahertz band introduced in Wi-Fi 6E? Well, so previously just 2.4 and 5, it got very congested. So in 2.4, you only have 3 channels that you can set your access point radio to. If it's operating in 2.4, you only got 1, 3, and 11. 1, 6, and 11. So in other words, if an AP was set to channel 1, the next AP over didn't have any choice but to be set to channel 6, and then the next AP over should be in good best practice design set to 11. And what made it worse is because at a lower frequency like 2.4 gigahertz, the cell sizes, depending on the setting, the power setting of the access point, in other words, how powerful the AP was transmitting the RF signal, 2.4 can actually go up to a mile. And the challenge with that is that as you do your design, as soon as you put 4 APs into a space, 1, 6, and 11, and guess what? Your next channel furthest away from your next AP furthest away from your first AP has to be back to channel 1 because it's going to be closest to the third AP, which is on channel 11. So you didn't have a choice but to use reuse channels. And if you had a fairly large deployment with many APs, you're reusing those 3 channels over and over again. With 5 gigahertz, you had up to 25. Give or take. I say give or take because there are some weather radar channels that some areas you just had to exclude from your channel list. But in 5 gigahertz, you had up to about 25, which made it difficult to go and start combining channels. When I say combine channels, I mean you take a single 20 megahertz wide channel and you combine that with another 20 megahertz wide channel and make that 40. Think of that as having more lanes on a highway. Instead of a single lane highway, now you have 2 lanes, 20 megahertz each. So you could potentially pump more traffic through or get a higher throughput. But then the problem is that now instead of having 25 channels or 24 channels, you're now down to 12. Well, guess what? In a high density environment, your first 12 APs are all on unique different channels, but then your 13th AP now has to reuse one of the channels previously. So, in any RF or wireless design, that engineer now is praying for attenuation in the space. What I mean by attenuation is things like glass walls, maybe a lot of people in that area to attenuate the signal so that he can put an AP up close to another AP on the same channel. And he doesn't have to worry too much about co-channel interference because there's a lot of attenuation in that space. Now here comes 6 gigahertz. And now you have up to 59 channels, and that's a lot. The FCC gave us up to 1200 megahertz of unlicensed spectrum to use in Wi-Fi 6E. So now you have a bunch of lanes on this highway, and now combining 2 20s to make a 40 becomes a reality. And you could even combine 2 40s to make an 80 and still be, depending on the environment, and still be okay. So But now we're going up in frequency, right? And what happens, it's just physics. What happens when you go up in frequency is that your cell size and the propagation of the RF doesn't get as far. So as I mentioned, 2.4 lower frequency, that can actually propagate up to a mile depending on power. Now you're up at 6 gigahertz, that cell size, AP cell size is much reduced, and it doesn't penetrate through walls and glass and humans nearly as well as 2.4. So those are some of the challenges and design considerations when you are designing a space to support the new 6 gigahertz Wi-Fi 6E space or band. As I mentioned, 2.4, if you couldn't even combine two channels because you are so limited in what you're able to use. And then in 5 gigahertz, if you only used 20 megahertz wide channels, you only had 25. And as soon as you start combining, you're down to 12. So depending on the use case, you could get away with 12, but that's the point. As an RF engineer, you start praying for, mediums or material in that space to attenuate the signal. Then potentially you could go to 40 megahertz wide. But now in the 6 gigahertz or 6E band standard, you have up to 59, 20 megahertz wide channels. So that's a huge advantage. And now 40 megahertz wide channels definitely is a reality, and even 80, depending on, as I mentioned, the use case. And even 160, or where you have now 7 channels in your pocket to help you with the design, is also possible, again, depending on the use case. Any questions? Oh, Tom Lawrence.
Yeah, this is just a high level question. You mentioned the U.S. and European standards here, but is it also include anything in Asia?
I actually didn't mention Europe yet, but since you did bring it
I'm
up,
just looking at the actual presentation. It says 500 megahertz of spectrum in EU.
Oh, okay. I'm sorry. Which slide are you seeing? The presenter slides?
Yeah,
Oh,
it's
you are.
the
Okay.
6 gigahertz section there.
Oh, okay.
I was
Yeah.
just curious because we have sites that are. Oh, okay. There we go.
Yeah.
Thank you.
Sorry. You threw me off because I could see my next slide, whether you
No
were seeing
worries.
this slide or not. Okay. So I see what you saw there. So yeah, in the previous slide, I think there was mentioned EU at the bottom right there, but here only in the US did we get all 12. Did the FCC say, yes, we're going to release all 1200 megahertz for Wi-Fi 6E. But there are a bunch of countries and regions that jury's still out. They haven't decided if so. For example, Australia, Japan, UK, Hong Kong, and Qatar, they're considering 1200 megahertz, but that doesn't mean Singapore and let's say Taiwan and China are. So yeah, jury's still out on that. So we are still a little bit challenged when we ship, because we do have Wi-Fi 6E supported access points that are available and that are available to order. And I was going to say ready to ship. They're not ready to ship because of some lead time challenges, but they're available to order. That now has to adhere to that country or region's FCC equivalent policies. So Yeah. So you'd have you're not gonna, 80 may not be a reality in that situation. So, but 40 definitely. So if you're talking again back to use case, if you're talking a office space or what I often refer to as carpeted space, um, 40 megahertz wide channels definitely will be usable, even in countries that are only supporting half the um, range of spectrum that they're going to provide for 6 gigahertz or 6E, sorry. Hopefully that helped you, Tom. But yeah, I would actually make sure you do your due diligence and your homework for those regions.
Yep. Thank you for explaining. Appreciate it.
Yeah, yeah, sure. Okay, so these are some classifications that the FCC have provided us. So you're going to hear LPI or low power indoor access points. That's what we at Cisco have available and they're ready to order. Um, we're not allowed to go to standard power yet, and that's because the in the US and as well as for the rest of the world actually, standard power is not allowed just yet because um, the 6 gigahertz band that the FCC released wasn't just found, right? They didn't just say, "Oh, look, we found 1200 megahertz you can have." What's happened is that 1200 megahertz wasn't widely used, so the FCC said, "You know what? Because it's not widely used, let's see if we can make it unlicensed and free for use for wireless or Wi-Fi." Well, the folks that were using it, of course, wasn't very happy with this. So they said to the FCC that, hey, if you start making this unlicensed, they're going to interfere with very important microwave communications in this frequency, and that could be a big problem. So the FCC said, okay, fine, we will let folks use LPI or low power indoor access points indoors because we know that 6 gigahertz won't propagate nearly as far. So if the AP is stood up indoors, the signal will pretty much stay within the walls of that office or that space. With standard power, when you go outdoors, now that's where the problem comes in. If you have one of these communication towers that needs to use the the same frequency, the FCC said to manufacturers like us to say, well, now you need to put a way for us to identify where the customer is installing these APs. And as soon as we know where they're installed, we need a mechanism to tell the AP, hey, you have to stay off the following channels, and you can only transmit at this power. And the reason for that control is because of interfering with existing, um, very important communication um, systems in that same frequency. So that's what we call AFC, or automatic frequency coordination. The frequency and power needs to be coordinated with a body, and the requirements are provided by the FCC, and this body is what the manufacturers have to coordinate with to provide location and ultimately power of the transmission. So that's standard power. That should all be kind of vetted out in the next, I would say, 12 months or so. So by next summer, we would expect that there's enough guidance and kind of guardrails for us to start deploying or shipping outdoor access points and be able to use antennas as well. And then, some of the specs for very low power AP, client devices, those are still yet to be determined. So right now we've got LPI, SP or standard power is being vetted out, and there's really not too much requirements yet for VLP or very low power. And again, regulations will vary by country. So I touched on some security challenges. Unfortunately, in this, the discussion around security can take up an hour by itself. So, but needless to say, we are WPA2 or PSK is what's supported up to Wi-Fi 6. But once you go into 6E, WPA3. SAE or simultaneous authentication of equals, and then PMF. Those are all must-have or requirements to operate in 6E. And so all of the client drivers need to support this, et cetera, which makes it challenging if as you kind of configure your access points. And what do you do for 2.4 and 5 versus 6E, et cetera, et cetera. So like I said, I won't dig into each of this, but I've kind of categorized this as, most flexible. So on the right-hand side, the first line item there is most flexible. The second line item is most conservative. And then the third, where it's just all in, right? Which will probably open up more tickets than you want to know about. Because that third line item basically says you're all in, you've configured WPA3 across all the bands, 2.4, 5, and 6, and you're just saying, that's it, I don't care, everybody has to just jump on this WPA3 bandwagon. Well, client drivers that come into your environment may not support WPA3, so hence your tickets, support tickets get generated. Having multiple SSIDs, so it's a bit of a redesign for your SSIDs, and then having specific SSIDs for each of the bands is probably the most flexible. So, and I think to be safe, I don't want to make any blanket statements. It really is down to what type of guests and where those guests are, and what you have to support, and also BYOD use cases. If it's corporate owned, this is something you want to coordinate with the client or the desktop team or client devices team to say, when's the next refresh, and all those devices going to be supporting the new 6E standard. Any questions on this? Okay, moving on.
Yep.
Go ahead, Michael.
Oh, no, I was just saying, it looks like we're all good.
Okay, great, thank you. All right, so one of our innovations and strive for RF excellence has been Clean Air, Cisco Clean Air. It's been around for quite some time, and we used to have a Sage chipset in our previous APs that would scan the airwaves for interference, be able to identify those interferers, and if you start combining that with, if you remember the days of MSE and CMX, we can even identify where those interferers are located on a given floor or area in a building. So now with 6 gigahertz, we have Cisco Clean Air Pro now supporting all of the challenges with the extra frequencies. Also, we've come out with a lot more radios in our access points. So, and we've also introduced artificial intelligence and machine learning with with an independent or dedicated scanning radio to support all of the things that and the challenges that come with all three bands. So I'm not going to read this to you, but you see mention of DNAC or DNA Center in each of these steps or workflow, roadmap versions. So each of these ultimately get exposed and can be consumed inside of DNA Center. So for example, in the third step to the right there, classification and reporting, we have machine-based interference classifiers. The scanning radio, as I mentioned, can detect and report on RF interferers. And then I'll talk soon about something we call air quality index and talk about some sensors that provide that air quality index. And then I spent a bit of time talking about AFC or automated frequency coordination integration. It's got 2 asterisks next to it because that's still yet to be vetted. And then IoT integration as well. So to us, there is an IoT, depending on the model of access point, there is an IoT radio. And so if you do have an IoT initiative either happening or about to happen, that's something you want to start considering as far as the model of AP you select, so that that is a dedicated IoT radio. So from a machine language-based perspective, Clean Air Pro provides the training of the machine learning part of it to classify the spectrum, and then from that classification, you start getting metrics and stats to start being able to identify what type of devices, as well as interferers that come into your space and ultimately are affecting your user experience. And obviously, the richer the data and the amount of data and how that data is mined and sampled, the better your results. So as I mentioned, there are 2 APs that we offer that have sensors in them. This is probably the first time we've offered a environmental sensor in the access point. So the sensors provide air quality measure, humidity, and temperature. The air quality is based on TVOC, or total volatile organic compound. And I did some research on what, or did some looking up on what TVOC actually measures, and it's kind of this sense of how clean, or the perception of cleanliness in indoor quality air is. So for example, if you've walked into a hotel room, for example, that hasn't been used for a while, and your first few steps, you can already tell that the air in there is pretty stale because the air conditioning hasn't been circulating the air, et cetera, et cetera. That gives you the perception of whether the room is clean or not. So stale air, bad odors, et cetera, et cetera, that all kind of adds to the stat that we classify as, or this TVOC sensor classifies as either good or bad air quality. Oops. Any questions so far? Okay. So this person actually wanted to test how sensitive the access point sensors actually is. I can't take any credit for the blog or the testing that was done. What he actually did was he provided the the necessary means to measure the sensor to measure the air quality, and then he used Cisco spaces. Notice I use the word Cisco spaces, not DNA spaces, because it's been um, branded as Cisco Spaces. So within Cisco Spaces is where you'll realize the digital readout of those sensors. So there's a little bit of a delay. Feel free to read this blog. I thought it was a fun read. I think, Michael, we probably lost most of the folks on the call now because they're probably reading this blog. But but it was a fun read. But anyway, as soon as it was about a 5 minute, there's a bit of about a 5 second delay between the time the sensors sensed the poor quality of air to when the readings actually showed. So in this case, he took a screenshot. Temperature went up, humidity went up. And then it dropped quickly because you'll find in the blog that I think he opened some windows, so the humidity and the particulates or the TVOC level counted in parts per million in the air was reduced, and hence the levels went down. So I thought that was interesting. Our QA folks didn't test it this way, but I'm glad this person wrote the blog about it because it definitely showed how sensitive the sensors actually are. Okay, so from a portfolio perspective, the Wi-Fi 6 environment, standard, these are the APs that support it. So you've probably heard of or seen this series of access points. And then the 91, 62, 64, and 66 are all Wi-Fi 6E ready. So if you just, and by the way, the mission critical or highest performing access point model, the 9136, is kind of off to the right and on its own. I'll tell you why in a minute, but it also has the most radios. So if you are wondering what all those numbers mean, the 4x4, the 8x8, 4x4 or 4x4. So the first 4x4 is the 2.4 band, and that band is able to transmit in 4 spatial streams. So that's using 4x4. And then we have 2 additional radios just dedicated to 5 gigahertz. So those 2 dedicated radios can actually be combined to give you 8x8. Or you can split them up, and each of those 5 gigahertz radios can do 4x4 each. And then you have a 6 gigahertz radio on the 9136 that can do 4x4. And then also there is a IoT radio on that 9136 that does 4x4. So so that's our flagship. It's got the most radios. And also notice it's got dual 5 gigahertz, 5 gigabits per second mgig ports on the AP. So that's the only, and for the first time, offering dual mgig ports on the access point. Now today you can actually connect those ports into the same switch, but for redundancy, connect them into 2 separate switches, and it will pull power from all the power it needs and to operate in kind of full capacity from one switch. And if that port or switch were to go down, it will negotiate and come up from the other switch that it's connected to. So there is no, the reason I'm explaining that is because there's no combination of power. So it won't pull 40% power from one switch and 60% power from the other, at least not in the version today. So to the left of that, you see the 9166. You see a little tag that says common hardware. I'll jump into that in a second. But also realize that there is only 3 radios, in that you got the 2.4, you got the 5, and then the third radio is an XOR. So it can either operate in 6, so that means this AP will support all 3 bands when it's in that mode. Or if you don't have any devices in the 6 gigahertz band in your environment, and you decide, okay, well, until such time I get more and more clients in the requesting 6 gigahertz, I'll just use it as a 5 gigahertz radio. You can switch that to having 1 2.4 and 2 5 gigahertz radios. Also notice that there's an MGig port, but only 1. So there's no redundancy. My recommendation is, if you have any new buildings or new spaces that you're renovating, it's a lot harder to pull a second cable once everything's built out. So if everything's torn up, or it's a new building coming up, it doesn't take much more money to drag or pull that second cable. So do it then, because this is kind of the early signs, but I can see that going forward, not just Cisco, but I think a lot more vendors will start looking at providing dual ports on their access points, so you have less single points of failure. Any questions on the portfolio?
I think we're good.
The 9167.
Yeah, so the 9167 is an interesting beast. It is the only AP that we offer that is 6E standard power ready. When I say standard power ready, you can't turn it on. You can deploy it, but it's when the AFC and all of the standard power has been vetted out, it will be ready to go. And it's also a platform where you can either bring it up in your catalyst mode. In other words, it comes up, it's looking for a controller, it joins the controller, it downloads the version of code that your controller is running or needs all of its APs to run, or you can boot it up in the acronym is CURB, but it's actually Cisco Ultra Reliable.
Wireless backhaul.
Thank you. Yes. I was getting there.
Yeah.
Thank you. But yeah, so that's the 9167. Was there a specific question on the 9167?
No, I just didn't see it here, and I know we just released it, so it was really, that was the area of interest.
Oh, okay. Yeah. Yeah, it is available for order. We just released it, but it's and it's also very ruggedized, so not so much for carpet space. It's definitely for more manufacturing, industrial, harsh environment, because it meets some pretty stringent standards for those types of use cases.
So that one has external antennas, and I noticed we have a choice of doing, omni or polarized. Is that anything you can talk to a little bit?
Which one has the 9167?
Yeah.
Yeah. So yes, you can use external antennas on the 9167, and then when the whole AFC standard power gets ratified or gets sorted out, then there will be an option of antennas to deploy that with. As far as external antennas for these access points, because AFC isn't completely sorted out, Cisco will be releasing a portfolio of Wi-Fi 6E APs that will support external antennas, but that's probably not for another year.
All right. And any guidance on if we should always pair a horizontal and vertical polarized antenna together as a pair as part of the MIMO, or do people just do one polarization direction if they know? That's just one area of ordering that's a little confusing to me.
Yeah. So my recommendation is we've done a really great job of making good recommendations with our deployment guides. So for example, if you look at the 9124 deployment guide, it talks about all the available antennas and how to best deploy them depending on the use case. And if you, I mean, unless there's a specific use case, usually I see either omnis or patches, depending on, you know, whether it's a very harsh RF environment or it's very high density, like a stadium or a lecture hall, or very high ceilings, et cetera, et cetera. But yeah, there is considerations such as enough separation so you don't, those antennas and frequencies don't step on each other, et cetera, et cetera. But yeah, our deployment guide goes into
All right.
quite a bit of that. Okay. So by the way, the reason why it says common hardware is because, as everyone knows, we do have a cloud offering, and that is Cisco Meraki, where you don't need a controller, a physical controller. All Meraki access points will phone home to the Cisco Meraki cloud, and the three APs here, the 62, 64, and 66, they can be ordered either with the DNA persona, where it joins a Catalyst-based controller like the 9800, or you can order it with the Meraki persona, where when it boots up, it straight away looks to get out to the Meraki cloud. So it's not going to come blank. In other words, it's not a blank slate. You have to order it appropriately, so that when you turn it on, it's one or the other. But it's common hardware because, let's say 6 months from now or some period down the road, you decide that you know, as a company, we're going all cloud. When I first ordered this, I ordered it with the DNA persona. Now I want to move over. I want to get rid of the controller and move my architecture to the cloud. You can reboot it with some licensing changes in the back end. You can actually have that AP join to the cloud, the Meraki persona, if you ordered it initially with the DNA persona. Now, that's a huge advantage because it's not the cost of the AP, and that's negligible, and the cost of the licensing is negligible. It's actually the cost of getting somebody to get up on a ladder to mount these things that just is the main pain and cost of doing a refresh or you know, blanketing a space with wireless or Wi-Fi. So with this, you design it once, you deploy it, and then you know, decide that you want to change the way you want to manage it. You know, that's the flexibility that this brings to the table. So I think I've covered most of these, but these you can, if you want to get into more specifics about the access, what each of these access points offers, feel free to download the slide, the deck, and refer to them.
Hey, Benny.
Yeah.
Hey, there was a question in regards to the 9136.
Mhm.
So if since there are two Ethernet ports on that access point, are we able to split PoE power, say, across multiple switches? So for resiliency purposes, so if a switch goes down, we're able to power it via the other Ethernet port, or is that not the case?
No, you can, and you can even lag them. the only thing that's not supported in the current version of code is the ability to draw, let's say, 40% of power from one switch and 60% from a different switch. So at the moment, you have to draw all, BT power, UPOE power from one or the other. But as soon as that one goes down, it will come up with the other switch. Does that answer the question, Michael?
Perfect. No,
Yeah.
I think it does. Lance, does that answer the question that you had?
Yeah. Yep.
Perfect.
Okay, sounds
Thank
good. Yeah, and it's the only AP with the dual ports and one less point of failure, right? Okay, I'm going to skim through this in the interest of time. And just to summarize, the top row are the Wi-Fi 6E access points. And just a quick mention, I know I talked about lead times. We've all been struggling with them. The latest announcement, or maybe it hasn't gone out yet, but I'll share it with you. We've gone now from 30 plus weeks down to about 14 plus weeks. So how did we do that, and what does that mean for you? So we did that because we have now, instead of a single source for the radio chipset, we have found multiple sources for the radio chipset. So, manufacturing has ramped up production, hence why the, nearly cut in half for the lead times. But also, be aware that there is a field notice. It's 72424 is the field notice number. If you Google it, you're going to be able to find it. But if you do get your AP after a certain manufacturing date, you actually need to look at a different code version because of the change in the chipset post that manufacturing date. So just be aware of that. Any questions on what I just mentioned? That new version, whether you're running 810 on an AirOS controller, 5520, 8540, or if you're running 17.3 on a 9800 or 17.6 on a 9800 of iOS XE code version, there is a code that you would have to install and upgrade to if you're going to deploy these access points that have been manufactured after a certain date. That field notice talks about how to identify the batch of APs that you get on your loading dock, whether you need to upgrade or not. And then the portfolio of APs on the bottom shelf are Wi-Fi 6 APs. So the difference, as I've talked about, is that 6E gives you that 6 gigahertz frequency range. My recommendation, actually, do I talk about it? No. So my recommendation actually is if you're not able to deploy a heterogeneous environment of all Wi-Fi 6E capable access points. So in a weekend, if a floor is rather large, and let's say you have, pick some number, 55 access points, and in that weekend you can only do half the floor, but that whole floor is a single roaming domain, then my recommendation is, disable 6 gigahertz, just enable the 2.4 and the 5 until such time that whole roaming domain can support, is upgraded and can support, all 3 bands. So you're not pushed or forced to, pull a 48-hour shift or something to try and replace all of the APs on that single roaming domain. Tougher if you have multiple floors in a building and you need to refresh all those multiple floors, and sometimes there's a a center opening in that building where the signal actually leaks through, and you potentially could, even though you're on the second floor, you could roam to an AP on the third floor. In that situation, I would then disable the 6 gigahertz until such time the entire building is actually refreshed with all 6 gigahertz capable access points. So that's my recommendation. Quick note on AP power optimization. We've now introduced AP power save mode and distribution. So now you can actually dial in schedules where, if let's say everyone goes home by 6 p.m. and there's not many people left in the building or nobody left in that workspace, have the AP turn off all its radios and not use nearly as much power as if all the radios were operational. With power distribution, if let's say there are clients that are not necessarily only using 5 gigahertz, why not turn down the 2.4 radio to only use 2x2 spatial streams, and take that power and push it to either the 5 gigahertz radio or the 6 gigahertz radio. So smarter use of power provided to the access points. And then, of course, reporting is always important. You want to show your management that there's efficient use of money, power, and ultimately funds. And so with DNA Center, you're able to generate these power saving insight reports to tell you how much money you've saved over time. And these are just for your reference, provided given what power level or power input power you provide to the access point, they will operate in various different modes. And I think with that was my last slide. Any questions? I think we have a couple of minutes for, maybe not, but I'm available for
Thank
questions
you. Thanks,
now.
Benny. Yeah, if there's any questions that you guys have, please feel free to come off mute and ask.
Yeah, thanks a lot, guys. This is great. Can I get a copy of this? This is recorded, right?
Yeah, absolutely. Yeah, we'll post the recording shortly after we end this session, and you can rewatch it there. We also do have a copy of the slides that I can send out to the group as well.
Great. Thanks, guys. Appreciate it.
Yep. Thanks, Tom. Appreciate you joining.
Sure. Have a great weekend, everyone, and go Phillies.
That's right.
Thanks,
Go
Tom.
Phil.